Hello everyone. In this problem, we will understand how to get Thevenin equivalent at terminal AB. Thevenin equivalent is basically a voltage source VTh in series with resistance RTh. This is our Thevenin equivalent. This is VTh in series with resistance RTh at terminal AB. Basically, VTh is open circuit voltage of that terminal and RTh is the equivalent resistance looking back to the terminal while all the independent sources are replaced by their internal resistances. So let's see. VTh is basically an open circuit voltage of terminal AB. Here AB terminal is open circuited, so our terminal voltage we can say this is VTh, and for this particular network we will calculate the value of VTh. In this network you can see a 4 ampere current source is connected in parallel with 6 ohm resistance. So here you can transform this by source transformation or you can solve this network as it is. According to source transformation, a current source in parallel with resistance, this is, you can transform this current source in parallel with resistance R by a voltage source in series with resistance. So this is a concept of source transformation. There the value of V is equals to I into R. So let's see the network. In this network you can transform this current source by using source transformation. This is our original network, 20 volt, 15 ohm, 10 ohm and 4 ohm. Our 4 ampere current source and 6 ohm resistance is connected in parallel. If you see the polarity, let's see the point of this network. This is C, D, E and F. In the 4 ampere current source, D terminal is positive and A terminal is negative for the current source. So here we will connect the voltage source in the same polarity and in connection with series resistance 6 ohm, and its value is I into R, that is 4 into 6, it's mean 24 volt. So A, B, C, D, E, F, these are the terminals and this is our voltage VTh. Now for calculation of VTh, first we define current in this particular network, then select a path for VTh. So here there is a single loop current I which is flowing in 15 ohm and 10 ohm, and 6 ohm current is 0, 4 ohm current is also 0 because its path is open. So here you can calculate current I, then select path. By selecting path A, B, C, D, A, you can calculate VTh, or you can select A, B, C, F, E, D, A for calculating VTh. So first we calculate I. You can directly calculate this current I. This is 20 divided by 15 plus 10, that is 20 by 25, or you can say 0.8 ampere, or you can apply KVL in path F, E, D, C, F, that is plus 20, minus 15i minus 10i is equals to 0. Here you can calculate, this is 20 divided by 25. So as you know, you can calculate this current I. This I is 0.8 ampere and its polarity is like this according to current direction. Now for VTH we will select path. For VTH it is path A, B, C, D, A. This is our path for VTH. A to B you can write minus VTH. This 4 ohm has 0 voltage drop, plus 10i minus 24, 6 ohm having 0 voltage drop. So our VTH equation will be like this: minus VTH plus 10i minus 24 is equals to 0. Here you can write VTH is equals to 10i minus 24, that is 10 into 0.8 minus 24, or you can say 8 minus 24. Our calculated VTH is minus 16 volts. What it's mean? It means a 16 volt source connected at terminal AB, where A is negative and B is positive. So this is our calculated VTH. Now let's see the calculation of RTH. RTH is basically an equivalent resistance looking back to the terminal while all the independent sources are replaced by their internal resistances. So here there is one 20 volt source and another 4 ampere current source. So 20 volt will be replaced by zero resistance and 4 ampere will be replaced by infinite resistance. 20 volt become short circuited and 4 ampere become open circuited. And according to this, our RTH equivalent will be like this. This 20 volt is short circuited. This is 6 ohm and 4 ohm, and this is open circuited. This is terminal A, terminal B, 15 ohm, 10 ohm, 6 ohm and 4 ohm. Here you can see this 15 and 10 is connected in parallel. So our reduced circuit will be like this. Fifteen in parallel with 10, 6 ohm and 4 ohm. This is terminal A, terminal B. So here you can say RTH is 15 in parallel with 10. Here you can see this combination is in series with 6 ohm and 4 ohm. So 15 in parallel with 10 plus 6 plus 4. You can calculate it: 15 into 10 divided by 15 plus 10, parallel combination, plus 6 plus 4, 10. So this is the 15 into 10 divided by 25 plus 10. 5 3s are 15, 5 2s are 10, 3 2s are 6, that is 6 plus 10. So calculated RTH is 16 ohm. So here we calculate VTH and RTH. Now let's see the Thevenin's equivalent. The Thevenin's equivalent If you see, it is a Thevenin's voltage in series with Thevenin's resistance RTH. This is terminal A, this is terminal B. This RTH is 16 ohm and our VTH is minus 16, or you can say this A terminal is negative and B terminal is positive. So this is our VTH, that is 16 volt. So this is the concept of finding the Thevenin equivalent at particular terminal. I hope you understand the concept. Thank you for watching the concept. Please like and subscribe my channel.